Hello everyone, and my name is Anton. In spite of the fact that I've been given a talk before on this meetup, until recent time I didn't work with Golang. So I came to Go from Node.js, and I was very surprised by the Go language ability to support testing. And today I would like to share my discoveries in Go language, what it provides us as a developers for testing of specifically for this example, HTTP services. What is typical HTTP service? Usually we expose REST interface. It could be Go, Post, Put, etc. It may have a business logic implementation, and it may also have an orchestration of external services to be able to fulfill the response to the caller. So telling the external service I mentioned, it can be any HTTP service, so it can be gRPC service, or it can even be a database. Before going to the test, I would like to mention some of the useful, sorry, this is the next slide. So for this presentation, I created a example service. It's called Go Calculator. This service has two endpoints. The first endpoint does a simple arithmetic operation, and the second endpoint does a call to the third-party service via provided URL and a query parameter, and it forward back the response from the third-party service. I'm using some of the design principles. Some of these principles intersect with what Dan mentioned before. So I'm using the interfaces to decouple the code from a concrete implementation. Again, if, for instance, if you need to connect to database or connect to external services, you would want to inject the client code to your service. While doing the injecting of concrete code, you may couple your service with implementation of the client. For instance, if we would want to save some information to the database, and later you decide, oh, you want to switch to file system, providing the database client to your methods is coupling your code with the concrete database. So what I would do, I would define the interface for repository in the package of my code, which will have minimum amount of methods to work with information, and I will initialize this interface on outer layers, so which is go to the second point. Dependency injections are unidirectional from outer layers to inner layers. Inner layer is the layer where you define your business logic, your code, and it exposes necessary interfaces and methods to talk to be able to accept information from outer world. Your business logic should not know anything about database or anything about web frameworks, etc. So let's get back to the testing. I'm going to talk about testing on route handlers. So here you can see the definition of route handler. It has two parameters, response writer and request. There is like usual route handler for Golang. My discovery was that I found this HTTP test package, which is subpackage of NetHTTP, and this package provides all the necessary instruments to write tests of our handlers. So it has a new recorder method, which allows us to create the response recorder that implements the response writer interface. It has a new request method that initializes the request, and it also provides a new server method that allows us to create a stub of HTTP server. I would like to share my code. Can you guys see the editor?
Yeah, it's good, and the font's a good size too.
Cool. So here you can see the definition of routes. I have a route map. I have a route for the do. I have do route, I have remote route, and then not found route. So it means when a request comes to any other route, it will hit this handler. And for not found handler, I will return the predefined response. For do handler, I will do some business logic and calculation inside the handler itself. And for the remote handler, I also inject the client here to be able to call the external service via HTTP. So this client is the interface defined in scope of this of the package, so that I can later make a mock of this interface. And here is the example of the testing. I'm using HTTP test package to initialize the request and initializing the response recorder, invoking my handler function, and then checking and validating the response from the handler function. And the same approach I use to test the do handler. Now, what we are going to do when we need to test HTTP calls. So usually we have a method that does HTTP calls. This method has an injection of the external service client. And I can see two options to test such codes. The first option is to provide to inject to your code, inject the service client mock. And the second approach is to stop the external service. For the injection or generation of the mock, I use the mockery library. It allows us to automatically generate mocks of the interfaces either in your package or in any external package. And to create a stub of the service, I use a new service method from HTTP test package. So here is how I test using the mock. First, I create a mocked response. Then I use already generated mock for HTTP client. And here I define the behavior of my mock when the do function invoked with the parameter type of HTTP request. I'm going to return predefined response. And the rest of the test is similar to what we could see for the previous two handlers. The further tests, I'm using the stub server. Again, I'm creating the HTTP server and predefine the response from this server. Created server gives us the URL, so now I can send a real request to that server and receive the response from my handler and assert this response. And the following is the example of testing of the other use case when we need to test the delay with response and see how our handler works with this. So while this type of tests, they help us to test the behavior, we can create, they're quite cheap. We can create lots of scenarios and test all of them. But sometimes you would want to test the integration between different systems and between your service and external system. And for this class of tests, I'm using the black box tests. I prefer to have an instance of my service up and running and instances of dependent services or services I depend on also up and running. For this, I'm using the Docker and Docker Compose, and to create and run the test itself, I'm using the Postman and Newman, which is a CLI version of Postman. So here you can see different variations of Postman testing. So on the left, far left, it's a completely local type of testing. So all systems running on your local machine in a Docker Compose context. Then hybrid option when some part of the system running in a Docker Compose context and the other parts are running in standalone mode, and then just purely standalone mode. So what stays unchanged in these variations is that the Postman test scenarios stays the same across all different variations, and the service implementation stays the same across all different variations. What changes is connect string between the Postman test and service and connection string from your service to external services. Here I have Postman collection with defined requests. For every request, you can generate the body. You can also generate a test which will verify response from the service. So if I try to send a request now, it fails. Nothing is running locally. I'm going to start a service. And here I'm going to see the logs. The service is up and running now. I'm going to send a request. Request is successful. Here we have multiple requests, and Postman also has a nice feature called runner. So I can pull the whole collection to the runner and run all requests against the instance of the service running. As soon as I tested the collection in UI, I can export that in JSON file and upload it to my repository. So it's available as collection here. And then I use Newman, which is a CLI version of Postman. It's distributed as npm package. So now I can run the same collection from my terminal. And you can see the log here. I log only error cases. So what it allows us to do, you can create a black box test in Postman, export the collection, commit to your repository, and then run the same test on your CI/CD environment. And I found it's very, very handy. So I think that's all what I wanted to tell today. Here you can see the list of resources I used to create the example project and to write an article and to prepare for the talk. Yeah, that's all. Thank you very much.
Thanks, Anton.
Thank you.
Any questions? I will upload the PDF of the talk to Meetup notes, and this PDF will have the links to source code and to article, to all the resources I used to use.
James, did you have a question there?
No, that was awesome. Thanks for sharing that presentation, Anton.
Yeah, welcome.
Oh yeah, Postman's like crazy full on. Someone just saying that Postman handled testing too. Yeah.
Yeah, looks like you can also create a stub of the services in Postman as well. So it's very very rich. So you can define different environments and switch URLs, and depending on what environment you are in. So yeah, using the Postman collection, I found really really advanced testing approach, I think.
So how did you get into using Postman in a more advanced way? Did you just pick it up from your team, or was there some?
It was just research, of course, because I think I was using it as like most of people use it, just to manually send a request to your APIs. And then I discovered the testability, and then I discovered that there is a Newman CLI version of Postman, and then if there is a CLI version of something, probably you can use it as CI/CD, and then discovered how you can utilize the collections to run your tests on CI/CD.
No, that seems really cool. And like writing the collections once and using them across, that looked really cool as well. Anton, can you read the chat? Have you got access to the chat? Can you see someone's just asked a question?
I'm using approach. I put code and test file in the same location. And can I share the screen again?
Sure. So have you used that in your go-calc? Have you organized it that way as well? Yeah.
Yeah, so here is my source code, which routes Go, and I have test. So, and I have validation and validation test. The difference is this test needs access to the private methods defined in routes. That's why it's called internal tests Go. Validator, for instance, exposes public methods. That's why I don't need to have just a semantics. I would like to know under what package it lives. So, and in test directory, I put the other code, which is integration test code, or they could be data generators or whatever. So I'm following the what's called the Golang project layout. So it has a very good definition of naming conventions of the directories in your project and what to put where. So that's how I approach this. So it's not it's not AWS Lambda if you're interested. Lambda Go, I define my functions that do arithmetic operations. So when we look at the routes, the do handler takes the operation and provides so that I have a map of available operations. So every operation has the lambda itself. Lambda has a calculation logic and it has a validation logic. So lambda is the functions that do the calculation. So the addition function, multiplication function, etc. And then instead of having this huge switch in do handler, I'm just adding new operations here. That's all.
So do you have any coding conventions? Like Dan was talking about some best practices. Do you guys have a coding convention that you have to apply? Like,
the mostly clean architecture. So like as I said, that try to create less coupled code, and this can be done with the help of interfaces. So whenever you need to connect to something else, it's better to pass the information via interface. And it took me a while. Like there is a principles of clean code architecture. It took me a while to understand it, but as soon as you get it, it's a pretty good approach to develop the code, and it can be applied to any language. So it's not language specific. The trick of Golang is that the language itself can support some of the principles. Again, like if compared to JavaScript, JavaScript doesn't have interfaces, and it's quite easy to make a detours in Java. Golang is stricter in this case. So I would recommend to read about clean code, 12-factor application. That's the main two pillars for me. In terms of naming conventions, etc., there are some coding guides. There is very good Uber Go style coding conventions, so they're good. And the coding conventions are made by Google team itself. So I will try to find the links, and I'll probably share it if I have them handy.
Hey, Anton, one thing one question I have, which is which I've had trouble with before with sort of testing HTTP services, is not so much around sort of that sort of initial sort of setup of the services, but sort of maintaining that sort of testing as as it evolves, so the maintenance of the tests. Do you have sort of any guidance around how to sort of like any experience or any sort of guidance around like sort of how to look after these sort of tests as they evolve over time, and like how to sort of like as those sort of as they change and evolve, like with versioning and those type of things?
Well, I probably have less experience and met less troubles than you. I just try to separate. First of all, I try to keep code separate to the test payloads. I would create a separate file which will have the definition of all this, let's say, JSON payloads.
Yeah, because I was looking at your example, like with the food power example, and I was working with teams, and they're just like and the stuff they're doing, they're like dumping, long strings of like checking, with the large JSON payloads, and I'm checking, that I forget the length of the strings, but you can imagine they would the strings were quite large, and it was like going over many lines. So and there was like, I think hundreds of these tests, and they were evolving over time. So the tests were becoming unmanageable over a period of a couple of years. So so initially the tests were okay, but it became sort of this nightmare that small changes in the payloads would break, and the tests would become such a nightmare around sort of, especially around sort of, because they were integrating with all these downstream systems, and it was just a way to sort of manage the way sort of the payloads were integrated in with the tests, and there was also dealing with sort of having to like file payloads and all those type of things. It was, you know, a bit of a nightmare in the end.
Yeah, so what I will do, I don't have much experience in it, but there is such thing as a fuzz testing. And if you abstract from the payload is just a bunch of information, like data that required by service to do some operation. So, and this service has some functionality. So I think you need to test the functionality itself. Yes, you would need these payloads, but if you want to test all permutation of what the function can do, I would test the function itself rather than generating the thousands of possible JSON payloads, if you know what I mean. If you look at the code of the source code of some of the DNS servers implementation, or like HTTP servers implementation, or some of the low-level servers implementation written by Google or whatever, you would find that they use this, I think it's called, the whole approach called fuzz testing, I think, where they test the behavior rather than generating the payload. Let's say you have a division functionality and you don't want to have a divider as 0, so you test around this. So I'm sorry, I cannot elaborate much about it because it's it could be the whole other topic, but it's a good question. What I would, again, definitely how I would approach this is to start looking into this area, this type of testing, rather than generating thousands of test payloads. It just starts happening.
Yeah, it wasn't so much, you know, there was thousands of, you know, test payloads, just there was, you know, thousands of, you know, APIs that were under test. So there was a lot of tests that were, you know, so there was a lot of, you know, the scale of the testing as opposed to lots of tests for one API. So it's just the way that sort of, you know,
if you keep different layers separate, so you may not need so many tests. So like if one layer just accepts and parses the request and then passes it down to the next level to validate, etc. So you can write a specific test for specific operations. So the one test for the validation, the other test for the parsing, etc. And in this case, you may not need, again, all these thousands of tests.
Yeah, there's a lot around sort of, you know, contract-based API testing. So yeah.
Hey, Darren, how long did those tests take to run?
They were pretty quick because they were just at that sort of contract sort of level. It was more around that sort of, so everything else was sort of mocks for that sort of downstream type stuff. So it was just to validate that sort of contract. So yeah, it was pretty fast in the pipeline. Yeah, so I can't remember the exact time, but it was, you know, it was reasonably fast. But it was more just around sort of the management of that sort of how do you, like, it was more the structure, the way the tests were structured, and being able to you know, pull requests around those sort of things are, you know, painful to do the code reviews because you know, and the structure of the actual, like the repos and stuff, it wasn't great. So there's a bit of refactoring to manage that as the code base grew. for the APIs and the versioning of that as as new versions came through. So there was a bit of a learning process as that went on. So I was just curious about people's experience around that.
Yeah, I shared a blog post. It's called property-based testing, and I think it's better explained what I tried to say. It's about the fast testing approach. Maybe it's worth to look at this.
Oh, interesting. Thanks.
Okay. So I don't think there's any other questions, but I think that was some really good discussion. Thanks very much for everyone who raised some questions, and especially Anton and Dan for doing their presentations tonight. So yeah, thanks everybody.